I'm going to be giving a talk today on migration from a commercial search engine, FAST ESP, to an open source search engine, Lucene Solr. So what will we cover? Some of the topics that I'll be covering today are an overview of the use cases that we were looking at, the content crawling issue, how you process your content, searching, and scaling for growth. And after that, I'll be available for questions. Please hold your questions until the end. So, who am I? I'm Michael McIntosh. I have over 7 years of experience with the commercial search engine FAST ESP. I've been in search for a long time. I was one of the earlier developers at Lycos. And I took a small hiatus after the dot-com bubble burst to work on accessibility technology for people with physical disabilities. But after that, I came back to work on search engine technology. One thing that's interesting is I still develop brain-computer interfaces. And recently, from all the Oracle conversations, it made me think that if they need something to measure the speed of thought as it applies to search engine technology, they can borrow some of my equipment. So who are we? We're TNR Global. We do a wide variety of projects. Our focus over the last few years has become primarily search and cloud computing solutions. So I'd like to see a quick show of hands. How many people here work with ESP installations? Okay. How many people here work with Solr installations? Okay. How many people here who work with ESP installations are migrating to Solr right now? Okay. How many of you intend to migrate at some point soon? All right. So migration challenges. So our clients depend upon FAST ESP. But we've seen the writing on the wall for several years after FAST was acquired by Microsoft. And even though FAST is, Microsoft says that they still support ESP under Linux for at least another couple years, from all practical standpoints, I've seen all the documentation and support vectors just evaporate. So even if it's on paper, in practicality, support is already finished for FAST ESP, especially on Linux. If you're very lucky and you know, if you look in the exact right place, and you also put in the keyword SharePoint, you can sometimes find what you're looking for, but that's few and far between. So our customers are not yet ready to migrate to Solr, but they will be soon. And if it's anything like I've come to expect from our customers, when they are ready to migrate to Solr, they will want to have migrated yesterday. So they'll expect a quick turnaround. So we're doing a bit of work up front to make sure that we have an exit strategy for them in place. And we can offer a fairly painless approach because they have many, many custom Python document processing stages that we don't want to have to port right away or in a hurry. So how do we provide an alternative? So the migration use case I'm focusing on is federated product search. So one of our largest customers has many, many millions of parts and services that they provide through their public-facing search engine. So the types of data that we deal with are XML feeds, we deal with PDF documents, and we deal with HTML content. So the XML feeds are often catalogs that contain many, many thousand products in them. The PDF feeds tend to be catalogs, but they're the print variety, and we try to extract meaningful information from the PDF format. And the HTML content, I call it unstructured there, but I really wanted to say chaotic. The HTML content that we deal with is primarily vendor websites that we index. But the very difficult thing about the data we deal with is we have no control over the PDF content or the HTML content. So they all have different formats, have different taxonomies, have different ways of classifying their data, if their data is even in a format where it's classified at all. So what's our approach? Internally, we are using something that we've started calling the Solr Search Platform. So instead of ESP, it's Solr SP. And one of the things that we've done so far is we've made a custom scalable web crawler. One of the things that we didn't anticipate that we would need is, in addition to a search cluster, we would need a crawling cluster. But the crawling needs of our clients continue to go up and up. So now we actually have to manage crawling clusters in addition to search clusters. So we found a good tool for that called Heritrix. I'll be talking about that. We manage events and queues with RabbitMQ. We have a persistence layer that we manage via RIAC, which is a NoSQL, distributed NoSQL solution. However, based upon the workshops that I've attended this week, one of the things that we might be looking at is migrating over to Hadoop, simply because of all of the nice tools that can utilize Hadoop. So instead of pushing things into RIAC and then having to push them into Hadoop for other analytics, we might just push them directly into Hadoop. We found almost an exact replacement for the ESP document processing pipeline called Pipes, and I will be talking more about that in a little bit. I actually had the most fun working on that part. And we can do advanced linguistics using the Natural Language Toolkit or a commercial product, the Rosette Linguistics Toolkit. So crawling content. So what do I mean by crawling content? It's slightly expanded. In this sense, I mean content acquisition. Anything we have to do to get any content, either off of a website, off of a local file system, out of a database, or out of an API feed, anything. So how we've managed crawling content for ESP is for our XML content, we have scripts that know how to talk to the feed services. There are thousands of feed services that we talk to, and out of those thousands, we download millions and millions of items that we have to transform. For the PDF, we get a list of PDFs, and we get some affiliated metadata that we can use for tagging it with. And we just grab those directly. So we grab them and cache them. For HTML, however, we get a seed list of URLs, and we get a very large seed list of URLs. It's many thousands of websites that we crawl. So even a small variance in the number of documents that the customer wants to crawl for them can equal many millions of additional documents that get added to the index. So for that, we use the ESP Enterprise Crawler to manage that. It's worked fairly well. It has sub-configurations, but unfortunately, it's very opaque. So it's hard for us to see inside of it to see what's going on. And that's been a sore point for years. So crawling for Solr. From our standpoint, for our use case, for the XML and the PDF data content issues, there's not much more we have to do. The only thing that changes ever so slightly is we use a different writer. So we write to a different location. For the HTML solution and crawling websites, that's a little more dicey. So one of the first things that we did was take a look at Nutch. We tried to make a good go at using Nutch for a while, the Nutch crawler specifically, but we couldn't really get it to do what we wanted it to do. And after a while, we gave up trying to hammer it into shape and looked around for an alternative. One of the things that we're excited to hear about was the new releases of LucidWorks Enterprise Edition that had crawling built right in. So we grabbed LucidWorks and we saw the crawler, but for our particular use case, for having many thousands of websites the interface that LucidWorks exposes isn't really appropriate for our needs. Overall, our impression is that a lot of folks that are using Solr, and potentially folks that are using ESP, they don't do a huge amount of crawling, or they certainly don't do the level of crawling that we do. So I'm not too surprised that, out of the box, LucidWorks didn't have a crawler that met our needs. So what we ended up going with is an open source crawler called Heritrix, created by the folks over at Internet Archive, who also made the Wayback Machine. And one of the things that we liked most about Heritrix is that it had the majority of features that the ESP enterprise crawler had right out of the box. The other cool thing about Heritrix is that they completely rewrote it within the last, I think, 2 years. So it's not kind of this, piece of software that's evolved over a long time. It evolved for quite a while, and then they stopped and they rewrote it, or they heavily refactored it to give it clean interfaces and to rethink their architecture. So we wrapped Heritrix in a higher level interface, as we're prone to do. Pretty much any time we deal with an open source technology solution, we always wrap it. So if we find a better solution at some point, we can swap it out and replace it without having to completely refactor the entire stack that we've assembled. And one of the things that we focus on internally is getting good at making software stacks, because since we've been working and doing search on the cloud and doing cloud computing, one of the hard lessons we've learned is just we have to automate everything, otherwise things are going to end in tears. So we provided a higher level interface to Heritrix. It's a RESTful interface. It's pretty simple to talk to. You can talk to it with any scripting language. We also, via the wrapper, made Heritrix scalable. So we can have a multi-node Heritrix install and send jobs to basically the job controller and have the individual nodes in Heritrix manage their part of the crawl, manage crawling the websites that they're responsible for. And we also added a persistence layer using React, where we store the documents so we can do refresh crawling later. So the initial time that you crawl a website, you obviously have to go and grab everything. But one of the things that we need and we depend upon from the ESP enterprise crawler is refresh crawling. We have a large number of very slow websites that we do not want to wait the weeks and weeks and weeks it takes to grab their content. So ideally, we only want to grab content if the document has changed. So with React, it's very nice because we can shove the HTTP headers and the body into React as a document, but we can also attach metadata like the last modified date to the React entry, and we've integrated that with Heritrix. So when we go to refresh a document, we do an HTTP head to see if the last modified date has changed, and if it's not the same as what's in React, we re-grab it. So this is what our current crawler architecture looks like for the scalable Heritrix. We have a crawler manager that's essentially the traffic cop. The crawler manager accepts job requests, and the crawler manager uses a RESTful interface and accepts JSON requests. But we've actually found that we might have to refactor that or change that slightly because we had a task where we needed to basically link check something like 100,000 URLs. So you don't want to shove 100,000 URLs in a JSON query over an HTTP stream. So at least not normally. So we'll have to rethink that. I think we'll have to add some support for via the JSON config, pointing it at some other location to grab the list. So we manage events in the crawler cluster via RabbitMQ. The crawler manager sends events to the Heritrix messenger. Heritrix messenger, when it sees events, it will kick off the Heritrix crawler. For a multi-node crawler configuration, we have on each node or each machine, we have Heritrix messenger running, and we have a Heritrix crawler there. And the crawler manager handles figuring out how to partition the content. I believe the strategy we're currently using is we're distributing as a hash on the domain. So one of the areas where that could be a problem is if you have one giant site compared to the others. But due to the normal use cases that we have, pretty much all the sites have an upper limit, and they'll hit that limit, so things will still be evenly distributed between the crawler nodes. We've replaced the ARC writer that Heritrix uses with a writer that persists to REAC, which we really like so far. And REAC is distributed. You can also tell it to replicate the data across multiple nodes, so we're not going to lose our crawler cache very easily. Again, like I said earlier, we may replace the persistence layer with Hadoop, so we can benefit from things like HBase or Pig or Hive or any of those other tools. So processing content. So processing for ESP. ESP processing is a document-centric processing pipeline. So what I mean by document-centric is if you write a document processor that does anything to it, like extracts text from a field or just does any operation, it's able to see everything else that document has. So you could have a classifier stage later on in the document processing pipeline that knows lemmatization has already happened. It can look at another field or a bunch of fields, and it can look at the metadata or the annotation for those fields and benefit from it. An even crazier thing that you can do in the ESP processing pipeline is you could instantiate a Python object. This is a little crazy. You could instantiate a Python object that's heavy to instantiate and you want to reuse, actually attach it to the document in the document processing pipeline for other stages further on down the road to benefit from before a final stage deallocates it before the document is tossed, before it gets persisted for indexing. So for the XML content, the XML content is the lightest, smallest content that we have, so it processes very quickly. I'm always sad when I start to process the HTML content because the documents per second that it processes at compared to the XML content is just, it's very different. So, you know, we transform the XML content into a Python format internally. We tag it with additional metadata. We classify the content before indexing. So for PDF, we're doing something a little special. Our vendors have PDF documents that are 10 megabytes or larger because they're product catalogs. And that is, if you get one of those in the search results and you have to download a 10 megabyte file and you still have no idea where your keyword is inside of that file, it's not a great experience. So we've modified our processing pipeline. So we split PDF documents into individual pages, which we feed those pages through the system as documents. We also generate thumbnails for each of those pages, and we store them in something like S3 or on a server somewhere, so that when the search results come up, it knows where to look to grab the thumbnail for that individual page. One thing that's interesting about PDFs is that the thumbnail generation is way slower than the page splitting functionality. So the thumbnail generation is actually a decoupled task. So the thumbnail generation will not slow the document down from going through the system. Eventually, the thumbnail will appear in the search results. For HTML, HTML is trickier for us to deal with. We normalize it. We fix the encoding. We do content cleaning on it, which helps a lot because we have to classify it. And we do things, we do Chrome removal, so we remove navigation elements. And we had to develop like some general heuristics for dealing with our content corpus that can do a pretty good job at content cleaning. If it cleans too much content because it can't figure out where anything is, it just feeds the entire document into the system. And that has a negative impact on the quality of classifications we do. But documents that we're able to do good cleaning on them, the classifier is able to do a very good job because it's not contending with a bunch of navigation elements that point off of the page that have nothing to do with the context of the page. So we tag it with metadata and we classify that before indexing. So Solr processing is field-centric. They have analyzer chains that can tokenize fields and perform stemming and various operations on the field. But unfortunately, as far as I understand, you can't really see what else is going on with the document, or you don't have access to other information that you also want to carry around that might impact an operation you do with a particular field. So for our solution, we're still using some of the Solr analyzers. We're allowing Solr to do the tokenization and the stemming, although we would prefer lemmatization. If you need lemmatization versus stemming, you can look at things like the Rosette Linguistics toolkit or the Natural Language Toolkit, tools like that. Based upon the class that I was just in a couple days ago, cascading looks very promising. It looks like it can do a lot of what we've done historically in the FAST ESP processing pipeline, but can do much more. However, our customers have a bunch of stages written in Python. So for our solution, we use stackless Python with pipes to make ESP stage migration less painful. So processing with pipes. Pipes is written in Python. It was developed by Eric Gomer and Matt Weber. I think they're here. And they, at least, yeah, both of them are ex-FAST folks. And they, like myself, really like the document processing pipeline that ESP had. So they made their own version. Something in pipes is there's a class in pipes called packet, which is pretty much functionally equivalent to the document class in FAST ESP. You can assign values to fields. You can annotate fields with metadata. So like if you had a URL field, you could also attach to that field all the different component parts of the URL. So it's pretty cool stuff. The other cool thing about pipes is due to how it works, I believe it uses coroutines. You could shove one document into pipes and get out multiple documents. So a good example of this is pushing a PDF document into it and then having pipes, having stages in pipes to split it up into the different pages. So for this slide, I put together an example of something that could receive a PDF. It confirms that, yeah, I did receive a PDF. It does a little bit of URL parsing, and then it splits it. So on one side, it splits it to a page splitter that breaks it up into multiple pages. So up until the page splitter component, it was just one document, but the page splitter component consumes the document and spits out a bunch of individual documents, one per page. And then text extraction is done on them, and then it's written out to our Solr SP platform. On the other side where it's split out to the thumbnail generator, and it's eventually written to S3. So processor migration. So this is a very simple example with the comment and exception handling taken out, just so that I'd have enough room to show it on the slide. So it's pretty straightforward. In an ESP document processor, there are two main methods. There's a method called configuration changed, and there's a method called process. Configuration change is called anytime the configuration has changed for the document processor, including when it's instantiated. So the configuration change method is very useful for loading metadata. So if you have some sort of lookup table, let's say you have a lookup table for top-level domains, and you want that in memory for your fancy URL processing stage, you would load it in the configuration change and keep it around for the life of the object of the processor. The process method gets called when a document actually comes into the system. So in this example, it's just a URL domain extractor. I'm just showing how you parse a URL, extract the domain, and shove it into a field, like if you want to do navigation or faceting upon domain. So pretty straightforward for ESP. So it looks like it's more code. It's actually less. One of the things I didn't show you for the FAST ESP processor is the FAST ESP document processor also needs an XML file that you have to load into a special location that tells the document processor which Python modules it needs to load and which classes and what input parameters that it accepts in the processing pipeline GUI. So you have two bits of things that you have to manage. And you can have all sorts of mysterious, bizarre behavior if you deploy a document processor and forget to deploy the configuration XML file for it. In pipes, the configuration for the graphical representation and the actual behavior is all in one place. So the graphical declaration is declared in the init. So when you're working with the visual editor, documents, processors get instantiated, and it automatically knows what parameters they support. So this supports the URL field parameter with a default URL, and it supports an outfield parameter with a default value of domain. So it's very similar to the other one, except the configuration changed and the process steps are essentially in the run method. So you grab some fields up front to figure out what fields in each document you're going to need to look at in the future. And then you basically have a loop where it's looking for documents in its queue, and it'll do the operation. If it ever consumes all the documents in its queue, like it runs out of work, it immediately yields. So pipes and stackless use basically a cooperative threading model. So you don't want to do anything that blocks for a huge amount of time. Otherwise, other processors won't get to do their work. So searching content. I've combined a little bit about indexing and schema also in the content section. So feature differences. ESP has very robust faceting, and it can be very fast, and it supports hierarchical faceting. They call them navigators in ESP. But you have to do it. You have to basically say at indexing time in the index profile that I'm going to be faceting on this field. If you mess up and your customer says, oh, well, I also wanted to facet on this other field, good luck with that. If you have a large data set and you need to make a modification to your index profile, you might have to refeed your entire data set just to add faceting support for this one field that your customer didn't think of when you were talking about the schema with them. So that has been a pain point with ESP, and I'm glad that Solr lets me basically be more agile and flexible. It is at the cost of basically some pre-optimization, but in the long run, it allows for more ad hoc sort of analytics tasks and just experimentation. In ESP, there's a lot of things that we never do because we're too afraid that it might break something, which might incur weeks of content reprocessing. So that's a very powerful feature that Solr is able to offer because it does things at query time. So Solr now directly supports hierarchical faceting for drilling down on categories. I think it's called pivot faceting. and it supports field collapsing, which we use a lot to collapse things like our split PDF documents. So we're only showing one page, even though there might be 200. And also product lines. So we don't do a search, and we see 200 results that are all the same product, variants thereof, for one company. We collapse on things like company ID or a combination of several things so that each company in the index gets a chance to appear on the first page of results. So the search interface. There's no direct equivalent of the FAST query interface, the FAST query language in Solr as far as I've been able to discern. The FAST query language is very powerful, very robust. We use a lot of the features. One we use a lot is the X-rank feature to basically boost results based upon certain criteria. While there isn't a direct equivalent of that in Solr, it does look like things such as function queries could be a possible replacement. Some of the queries that we have to put together for our customers are very convoluted, very complicated, and we've just started looking at function queries as a possible way that we can model some of the same behavior. If you don't have super complicated queries, you can look at eDismax and Dismax, and there are simpler parsers, but pretty much for the level of complexity we deal with, we start at Dismax. So Solr doesn't appear to really come with a nice search front-end engine that you can easily modify and make attractive and use for prototyping. It does have some of that, but ESP comes with the search front end, and they have like a nice guide on it, how to extend it, how to add all the functionality. So Solr doesn't have something like that, but we found something called TwigKit, which we really like. We heard about it last year at Lucene Revolution, and the TwigKit guys are very nice folks. We've started to look at it from the standpoint of using rapid application development to make mock-up interfaces for customers, for potential customers, and also for fleshing out analytics interfaces. So we're talking with them about using TwigKit more, and it's definitely worth checking out. And TwigKit also works with FAST ESP. So the stemmers that ship with Solr aren't as good as the ESP lematizer. So you really want to consider something like the Rosette Linguistics platform or the Natural Language Toolkit. For our high-end ESP customers, we really think that they're going to want to use something like Rosette. And also, if you didn't know, FAST ESP internally licensed Basis Technologies software. So ESP is already using the precursor to Rosette, and they've done a lot of work on it since then. So for anyone who is a hardcore ESP customer that wants really good lemmatizers, that wants to support multiple languages, you should really look at Rosette from Basis Technology. The Natural Language Toolkit is a Python module. We were very excited about it a couple years ago, but the license at the time prevented us from actually using it with any of our work. They've relicensed it, so now we could use it with anything, and it's very viable. It has built-in lemmatizers. It has all sorts of cool things in it. And if you're going to use it with pipes, they're both in Python, so they're very trivial to integrate. So scaling for growth. So about the hardware. If you're a FAST ESP customer, you're familiar with the row column cluster layout. You can have search services on the same node as indexers. You can have a row of indexers, and you can have the search service that the index is pushed to. So Solr supports things like that. In Solr, columns are called shards, and rows, as far as I can tell, are called slaves. So basically, you're replicating, and you have the search. You have a copy of the index elsewhere. So Solr has that. We're currently using a master-slave configuration for the index and search things, so we can index to the indexers and then eventually push to the slaves. But there are a huge number of options there. One of the things that we're looking at, we've always had a difficulty scaling FAST ESP clusters. We've always wished we could just say, I want to add a column and have it magically work. We have done it, but it's a very painful process, and it's very prone for errors and just spooky, weird behavior. We did that once, and we happened to deploy an ESP that didn't have the same patch level as the other nodes in the cluster, and it didn't fail. It just acted a little weird, and it took us a while to figure out what was going on. So we're looking at things like Dynamo, things like how REACT is implemented for basically a circular partition as a way that we can dynamically scale a Solr cluster and just add a machine and have it automatically redistribute basically shards or cores to the new machine after a while, and have things in place that can cope with duplicates of items being returned in the search results. So we're very interested in that. That is something that we hope to put together over the course of the next few months. Unless someone else has already done it, we're going to be looking around, but we haven't seen anything yet. And that would address a pain point for ESP that we've had for years. So the other thing is that scaling for growth is not just about the hardware. It's about procedure. You can have a large cluster, but if you're doing anything manually, you're not going to be very fast or agile, and you're probably going to have a lot of messes to clean up because you have to account for human factors and human error, and it's impossible to do the same thing correctly all the time. So to try to address that, we use something called Fabric, which we love. That we use Fabric to install Solr clusters. We use Fabric to build data, and we use Fabric to deploy configuration changes and build and to deploy metadata. Like one of the clever things that we did with Fabric with ESP is our Fabric task has a decorator that you can specify the name of the admin node for an ESP cluster. Fabric automatically will talk to the admin node of an ESP cluster and get a list of roles and host names associated with those roles. So for our Fabric deploys, when we're building data that needs to go to the document processors, we're able to have a Fabric task that's able to automatically say, I want this to be run on all document processors. So we select it by role, and it's just magically pushed to all document processors. And you can specify multiple roles. So it's very powerful, and we intend to do the exact same thing with our Solr config for the Solr SP platform. And in fact, we've already started doing that. There's not the same exact kind of roles, but we're almost there, and it's very powerful stuff. But to automate your Fabric tasks, you can use a higher level tool, which is Jenkins, which is a continuous integration tool. So we use Jenkins to automate, manage, and track our Fabric tasks. So we can kick off a build, or a customer can actually trigger a build if they've updated some data via the interfaces that we've opened to them. So it can occur automatically. And once the build completes, we have a manual approval stage where if we approve it, then it's persisted to the cluster. Because we don't quite trust our client to push things to the cluster yet. So Jenkins is very powerful for that. It's also known as Hudson. That's a long sordid tale, but you can Google it. We also use Supervisor. Supervisor is very cool. One component of ESP that I also like a lot is the node controller. And I don't know if anyone else has paid attention to the node controller, but it does a lot of cool things if you actually look at it, but it's something that you use for everything. But essentially, the node controller manages services and keeps them alive, and is also responsible for communicating to things like the administration nodes to let them know that these services are up, these services are down, here's what's going on. Supervisor has the same functionality, and it's very cool, and we use Supervisor in pretty much any software stack that we put together, it's a very useful tool. So also along the lines of scaling, you have the option to use LucidWorks for a better out-of-the-box Solr experience. If you're a FAST ESP customer and you're used to paying the ESP licensing fees, and you're very nervous about just going over into open source without a life preserver and a support or anyone to blame, you can use something like LucidWorks. LucidWorks ships with a lot of cool bells and whistles that don't ship with standard Solr. There's a alerting layer. There's a lot of additional service layers. I know that the stemmer that comes with LucidWorks out of the box, I think, is better than the default stemmer that ships with Solr. And they offer support. Not only do they offer support, but they're working with Trunk. They're working with the latest and greatest version of Solr. They have a lot of the committers on their staff, and they've essentially QA'd the choice bits of Solr, and you can take advantage of all the newest features of Solr and get support for it as well. Normally, we would never push anything in Trunk out to production. We'd only push things out in releases, but they manage it. They take the heat for that. They've QA'd it, so it's very nice. So our migration experience in a nutshell. We now consider Solr as a viable replacement for ESP. It doesn't have all the functions that we want or need yet. It has the majority of them. Some of the functionality we might have to implement ourselves. I know that we are using Solr in a distributed capability, and some of the functionality in Solr doesn't work in distributed mode yet, and we need some of that functionality to work in distributed mode. A lot of things have started working there, so that's good. You supply the glue, or you work with a company like ours to put the different components together. If you have a lot of custom ESP document processing pipelines, like 60 or 80 or 120, then you really want to look at pipes. Pipes can let you get into Solr faster than if you had to migrate all of that code over to a new solution or a different language. Like I mentioned earlier, LucidWorks, they provide a version of Solr that they offer full support for. So if you need something to lean on in terms of support, or you need to be able to sell it to higher up folks in the company that won't let you go with just a pure open source solution, you can work with LucidWorks and use that and get the support and a lot of the cool features. I've put together a slide that outlines the websites for the resources and the tools that I mentioned during this presentation. When the presentation is distributed, you'll have that list right there for you. Okay, are there any questions about what I've talked about or any of my ESP experience or Solr experience? Okay, so the question is, how do you support partial document updating in Solr, especially if you're used to having that feature in FAST ESP? Is that it? Okay, so that is not a feature that we've had to support. I do know that we looked at doing partial updates in FAST ESP, but I talked to FAST developers at the time, and this was several years ago, and the answer I just got from them is, don't do that. But they also said the same thing to me when I actually wanted to use the scope field feature as well, or content collapsing. So I think that you can probably do partial updates in Solr kind of the same way that FAST does. I don't know exactly how they do it, but I'm pretty sure that they have a reference to the FAST index XML document. They know where it resides in the FAST index XML cache, are able to grab it back out and push it through a custom document processing stage to just basically retag it. So in Solr, you know, I've got to think, well, one of the things that Solr doesn't have is Solr does not have like a persistence stage before indexing. And that's actually something that we've added with Solr SP, because our document processing is the most expensive thing. And we don't want to have to do it again. If we modify the config, we want to just be able to push the content right back through Solr. So we use React. After the document processing stage, we write to React, and we have a post-processed cache of the data that if we change something in the schema or the configuration, we can just feed that content back through. And that's one way that we could actually possibly do it, because we know exactly where each document is inside of React. Like if we have the URL, which we use as the doc ID, we know exactly where it is. We can grab the processed version of that and push it back through a pipeline. So you can definitely do something like that. It's probably easier if you have a persistence layer right before you do the indexing of your content. You might be able to query for it and yank it out and do something, but I don't think that would work very well. So the question is how do you have similar functionality to the FAST ESP search profile that can govern how queries are performed for basically a set for profile for configuration. So we haven't had to replicate that functionality exactly, but some of the things that you can set in the search profiles is I want these fields and I want these facets and things like that, or navigators. So there's a couple different approaches to that as far as I can tell. So if you wanted to have a federated search across multiple basically cores that have different schema, one of the tricks that we've seen, and it's also documented on Stack Overflow, is you can have a core that has no content in it. It has a unified schema or a reduced schema that only has the fields that you're interested in, and you use a sharded search. So that is the first shard that you hit. That's the one that you actually send the query to. So it doesn't have any content, but it aggregates all the content only into its fields. So if you had an empty core that had a schema that had title and body and something else, and you had all this other schema that had all these other things, but they also had title and body in addition to a bunch of other metadata, it could come through with that schema with the restriction, or you could make a schema that has all the fields that all the schema has and just hit that one as the query. Now, some of the things that we do with search profiles is sometimes there's a data processing issue where data before a certain time range, we don't want it to appear in the search results. I'm not sure exactly how to do something like that, but I do know that Solr supports via some mechanism URL rewriting. All right, well, thank you for coming to my presentation. If any of you need help for ESP to Solr migrations, please feel free to drop us an email or contact me directly. Thank you.